Good afternoon, everyone. My name is Sandile Ncongwane. I'm an outgoing intern at the Mandela Mining Precinct. Been here for the past 18 months or so, and then I'll be presenting to you guys today one of the projects that I did, or rather, one of the projects that I did at the Mandela Mining Precinct, which is the review of pneumatic versus hydropower rock drills, which belongs to, or rather falls under the longevity of current mines program at the precinct. For agenda, today we'll be talking to you guys on my introduction, research outcome, Isidingo drill challenge, automation of board and pillar operations, research project, as well as the conclusions thereof. For the objective of the main project that I will be, because I will be focusing on 3 projects that I undertook at the precinct. The first one is the review of the pneumatic versus hydropower rock drills. And then the second one will be, I will be touching base on the Isidingo drill challenge, how the 2 projects link together. And then the final one will be the automation of board and pillar operations. But for the aim of the first project, the review of pneumatic versus hydropower, the aim of the project, or rather this, is to study the best energy delivery system, which is, or you can refer to it as the power source that can be used in narrow reef hard rock mines, because pneumatic handheld equipment has proven to have limitations when it comes to delivering the best energy, since they are only limited to compressed air as power source. And then the issue with compressed air is that over time it has proven, studies have proven that it has become ineffective because of its low efficiency as well as its susceptibility to leakages. And then the main objective then thereof is to find the alternative power source to compressed air, and then investigate the relationship between the relationship of this particular project to the Isidingo drill challenge. So in me conducting the project, I focused on these 3 major questions. From the objective above, the questions that then arose were: what are the current limitations of the system that we are currently employing, the pneumatic handheld rock drills, what are the current limitations? And then I also questioned, okay, what would then be the benefits of now employing hydropowered rock drills as compared to the pneumatic ones? And then also focusing on health and safety. If we are to make the shift to hydro-powered rock drills, are these rock drills operated remotely, meaning is the operator removed from the dangerous working place such as the phase? So throughout this presentation, I'll be trying to answer basically these 3 questions. And then the compressed air limitations are that there's limited compressed air pressure, which then now requires an increase in air pressure as well as a higher consumption of air, which then leads to health and safety issues such as the increased transmission losses. And there's also, like I've mentioned before, there's the issue of leakages when it comes to compressed air. So if we are to increase your consumption and then you increase your air pressure, you are bound to have issues. And then the hydropower rock drills, based on literature review and research conducted, they have proven to have improved accuracy, efficiency, safety, as well as cost saving, because they, as I will be discussing in the coming slide, that I think the Isidingo drill challenge now then comes into effect, because if you look at the slide, or rather the, the slide that I have here is that I've got 2 hydropower rock drills from 2 different OEMs, the HPE and the Novatec one. So what could be observed is that these prototypes are remotely controlled, as can be observed that the operator is away from the dangerous working place, or rather we can say it's away from the face, and then in both cases. And then they've also, based on the test that we conducted, they've proven to be faster than the pneumatic handheld rock drills. They've also been weighed, and they weigh less, they're lighter than and they are more accurate in that they conform to the standard of parallelism. The drill holes conform to the standard of parallelism. Then moving right along to another project that I was part of, is the automation of board and pillar operations in narrow reef hard rock mines. So basically this one we're focusing mostly on literature review due to the COVID-19 limitations that we've been experiencing for the past year or so. So my main, or rather my key responsibilities, I focused on literature review on research work undertaken locally and internationally within the mining and minerals industry. I undertook motion and time studies on identified mining engineering technologies at various mine sites, as well as engaging with OEMs on these particular technologies, because we needed to understand, or rather we want to move the current level of automation at the board and pillar operations in narrow reef mines to the next level of automation. So during the project, we discovered that the system, you cannot change the whole mining industry. You can't move it from one level of automation to the next in one go, but you need to go system by system, or rather activity by activity. And then I reported on processes and results obtained during underground test work and monitoring work. And then attended and presented on results whenever deemed necessary. And then I also performed general administrative tasks as required by your project leaders. And then on my rather research project conclusions, and then in summing up in summing up the presentation, and then going back to the questions I asked at the beginning of the presentation, and then answers to those questions, is that there's been an increase, there's been an observed increase in the focus, there's been an increase in focus on hydropower, and then the industry is slightly shifting towards hydropower, and as we have rather demonstrated by the Isidingo Drill Challenge that yes, indeed, the industry is making that shift towards hydropower, and then also the automation levels. And then, as I've mentioned before, that there's different automation levels when it comes to a narrow reef, or rather in any mining site, there's different levels depending on that particular activity and what level of automation it's at. So, and then I will then conclude, and also I would like to thank you for giving me the opportunity to present to you today.